All right, let's just jump right in. There's a new kind of computer on the horizon, and I'm not talking about a simple upgrade. This is something that could literally change everything we know about our world, about technology, and even about ourselves. Just look at this number. That's a 1 with 30 zeros after it. You know what that's called? 1 nonillion. And this isn't just some crazy abstract number. It's real. This represents the insane processing leap that Google's new quantum chip has made over the fastest supercomputers we have today. Okay, so to really wrap your head around that number, check this out. Imagine a super complex calculation. For the world's most powerful supercomputer to solve it, it would take, get this, 500 trillion times the age of the entire universe. That same problem, Google's quantum chip knocks it out in 5 minutes. That's not just faster. It's like playing a whole different sport on a different planet.
And I really want to be clear here. This isn't sci-fi anymore. This is happening. We are literally standing at the dawn of a new era, the quantum age. An age powered not by the silicon and circuits we're used to, but by the super weird, mind-bending rules of quantum mechanics.
But, to really get where we're headed, we kind of have to look back at how we even got here. Because this search for more and more computing power, it's not a new thing. It's a story that's literally thousands of years old. And this timeline really tells the whole story, doesn't it? We started over 2,000 years ago with something called the Antikythera mechanism, an incredible device of bronze gears that could predict eclipses. Fast forward to the 1800s, and you've got Babbage's steam-powered analytical engine. Then, bam, we figure out how to harness electrons with vacuum tubes. Then we shrink it all down with the transistor. And finally, the moment that changed everything, the microprocessor, putting a whole computer on one tiny chip. That's what kicked off the digital world we all live in now. Yeah, that last step, the microprocessor, it's been the engine of our world for half of a century. It's the whole reason you're carrying a supercomputer in your pocket. But here's the thing. That amazing era of progress, it is now slamming into a hard physical wall. It all comes down to this one prediction, known as Moore's Law. It basically said that the number of transistors we could cram onto a chip would double about every 2 years. For 50 years, this was the reliable heartbeat of the tech world. It's why our phones, our laptops, everything got way more powerful, way cheaper every single year. You could practically set a clock to it. So here's the problem. The only way to keep Moore's Law alive is to keep shrinking those transistors. But we've now gotten them down to the size of just 20 atoms. I mean, think about that. And at that tiny scale, physics gets weird. The little pathways for the electrons are so narrow that the electrons literally start to jump off the path, tunneling right through the walls. It's this bizarre quantum effect, and it makes the whole circuit just stop working right. And what that means is, well, a major slowdown. That reliable 2-year doubling cycle, it's now taking 4 years, sometimes more. The incredible exponential growth that built our modern world it's just grinding to a halt. We've hit a massive technological roadblock. It's funny. In a way, we've been here before. Think about it. The ancient Greeks who built that Antikythera mechanism, they were limited by how perfectly they could shape their metal gears. Today, we're limited by the crazy quantum weirdness that happens when we make our silicon transistors too small. It's the same problem, just at a different scale. The fundamental laws of physics are telling us you can't go any smaller with this technology. So what's the solution? Well, instead of fighting these weird quantum effects, the next great leap in computing actually uses them. See, your computer right now uses bits. They're either a 0 or a 1. Simple. But quantum computers use qubits, and thanks to a wild idea called superposition, a qubit can be a 0, a 1, or amazingly, both at the exact same time. It's like a spinning coin before it lands, but it gets even crazier. With another thing called entanglement, you can link these qubits together. It's like having 2 of those spinning coins, and the instant one lands on heads, you know the other one instantly lands on tails, no matter how far apart they are. By using these 2 tricks, quantum computers can chew through a mind-boggling number of possibilities all at once. So yeah, that brings us to the real question, right? A computer that's a non-zillion times faster, it sounds cool, but what does that actually do for us? What kind of massive, impossible problems can we finally start to solve? Well, the possibilities are, honestly, they're staggering, and we're not talking about just making things a little bit better. We're talking about a fundamental shift. This tech could potentially let us extend our lifespans to 150, maybe even 200 years. It could help us eradicate almost every human disease, from cancer to Alzheimer's. We could simulate things like wormholes for space travel, figure out exactly where to look for alien life, and maybe, just maybe, achieve a kind of digital immortality by uploading our consciousness.
The key to all of this, the secret sauce, is something called quantum simulation. See, right now, even our best supercomputers can't create a perfect model of something as simple as a caffeine molecule. But a quantum computer could. It could build a perfect one-to-one digital twin of reality, down to the last atom. So imagine this. You could simulate exactly how a protein in the brain misfolds to cause Alzheimer's. And then in that simulation, you could test millions and millions of different drugs to see which one fixes it and find the answer in minutes. That's how we could potentially wipe out diseases that have plagued us for all of human history.
Okay, but before we all start planning our 200th birthday parties, we have to actually build these things. And that brings us right back down to Earth, to the here and now, where there's an absolutely fierce race going on to figure out how to make this quantum future a reality. And it's a massive hurdle, for sure. The quantum computers that exist today, they're gigantic. They're these delicate, room-sized machines that have to be kept colder than deep space, near absolute zero. So the single biggest engineering problem right now is, how do you shrink all that down? How do you take this hyper-complex beast and turn it into something that can actually be used in the real world, maybe even one day in our homes?
And you better believe this is a high-stakes race. The biggest names in tech, we're talking Google, IBM, Microsoft, Amazon, Intel, you name it, they're all pouring billions and billions of dollars into this. Everyone wants to be the one to crack the code and build the first truly useful, world-changing quantum computer.
Which, brings us to what might be the most profound part of this whole story. Because this technology isn't just about better phones or new medicines. It has the potential to fundamentally change us. So let's talk about what this really means for humanity.
I mean, listen to this. People are seriously talking about uploading our consciousness to a chip or a robot and basically becoming immortal. This isn't just some fringe idea anymore. It's a real possibility on the table. And it's easily one of the most transformative and, one of the most controversial ideas out there. And that just opens up a Pandora's box of huge questions, right? What happens to society when people start living for 2 centuries? What are the ethics of digitizing a mind? If we can fundamentally change the experience of life and death, what does being human even mean at that point? Because in the end, this leap to quantum computing is just as big as the leap from those ancient mechanical gears to the first electronic circuits. This next revolution, it's not really about getting faster gadgets. It's about finally having the tools to understand the universe at the deepest, most fundamental level. And when we can do that, we gain the power to redefine not just our world, but ourselves.